When you think about roller coasters and how it relates to the world's science, you probably think about physics. But today I'm going to show you the chemical side to a roller coaster. It is much easier to look at a roller coaster and relate it to physics, as you can talk about how it uses energy, whether that be potential energy, kinetic energy, speed, or mechanical energy. And while it is much easier and probably much more fun to relate physics to a roller coaster, I find it very interesting the amount of chemistry that is involved with roller coasters too. Now, there is so much chemistry involved with roller coasters and the reactions that take place. I will briefly skim the surface with multiple different reactions, but there are two main reactions that I want to focus on in this video. The two reactions that I will be mainly focusing on today are dopamine, the sense of feeling some sort of pleasure, and adrenaline, the fight or flight sensation. While these are the two most consistent reactions a roller coaster offers, there are many more reactions that take place on a roller coaster, and I want to give some brief examples before we do a deep dive on the two I just stated. Going back to physics for a minute, the law of friction very much affects every roller coaster, as it is what causes energy to be lost as the coaster travels through its course. When friction is created, a roller coaster slows down, which is why the elements get smaller on a coaster as you get closer to the end of the ride. But how is this related to chemistry, you might ask? Well, in most cases, a steel roller coaster uses a polyurethane style wheel, and when friction is applied, it creates a reaction causing the wheels of the coaster to melt over a certain period of time. This chemical reaction is a part of a physical change, and it requires the wheels to be inspected and changed very often. This reaction isn't the same on every roller coaster and is actually very inconsistent. On coasters like Intimidator 305 and Fury 325, the polyurethane wheels will need to be changed out much more often than on a coaster like Mystery Mine. Due to the consistent high speeds and heat created by the coaster's wheels, this makes a reaction happen a lot faster than on a slower coaster like Mystery Mine. In some cases, these reactions happen so fast that there will be sprinklers in the station to spray the wheels with water and cool them down. While speed definitely affects this reaction, it's not the only thing that causes it to be extremely inconsistent. Not all roller coasters use polyurethane wheels, which means that the reaction cannot occur on some coasters. On wooden coasters, there are steel wheels riding on steel track. Now going back to a physical perspective, this creates a lot less friction, which means that the train will not slow down as much as it travels the course. But this video is not about physics. Because the wheels are metal and it's riding on metal, there's not much of a reaction there. There are also coasters with just wooden wheels and even rubber tire wheels like on a car. All have a different and very inconsistent reaction like the usual polyurethane wheels. Another very inconsistent chemical reaction of a roller coaster is the physical change of the coaster itself. Over the course of many years, coasters will start to physically look different. This could be the reaction of paint fading or wood aging. In both cases, this reaction is very slow and is also extremely inconsistent, as the build quality of every roller coaster is different. So, the reaction is different on every coaster. A coaster that is exposed to the sun will fade faster than a roller coaster that is in the woods or in the shade. This reaction is known as photodegradation, or the process of UV attacking the chromosomes of paint. Same goes for the color of the coaster too. A color like yellow or orange will fade much faster than a color like green or purple. Some wood will age faster than other wood, and depending on the specific location it has on the coaster, it will wear out faster too. Just like wheels. This is known as oxidation, and the only difference is the UV is attacking wood and not paint. Also, wood in high stress areas of roller coasters will have a much faster reaction than wood in low stress areas. Think about the top 4 layers of track on a wooden coaster. This will wear out much faster than the bottom 4 layers because it gets exposed to the train traveling the course much more. Another example is the wooden cross sections. The wooden cross sections of track will wear much faster than the wood on the structure. Now it is fun to think about us just skimming the surface of chemistry and how it relates to a roller coaster. But I really want to deep dive into the two reactions that I mentioned at the beginning of this video. These are much more consistent than any of the reactions we just talked about, and they don't happen to the physical roller coaster itself, but to us, the riders. In my opinion, it makes it much more interesting to talk about because it's a true chemical reaction that occurs when we ride our favorite roller coasters. In case you forgot them already, I'm talking about the reaction of dopamine and adrenaline. Let's start with dopamine and give it a quick overview of what it is before we relate it to roller coasters, and how it affects you when you ride a coaster. One quick Google search and this is what comes up. Okay, well, I think it would be more beneficial to all of you watching to have someone who is more certified to give a better explanation.
Dopamine is a monoamine neurotransmitter, a term that refers to its chemical structure and the fact that it is derived from an amino acid. Dopamine is also a catecholamine, a term that also refers to its chemical structure and the fact that it contains a catechol nucleus. To synthesize dopamine, the amino acid tyrosine is converted to L-DOPA. Then L-DOPA is decarboxylated to form dopamine.
I think a better way of describing dopamine is calling it a feel-good chemical that is released when your brain feels pleasure, sense of reward, or motivation. These can be good and bad things. Eating a bunch of junk food and drinking soda are great ways to release dopamine, but they're not always the best for you. Getting the motivation to do better for your health, like playing sports, completing massive projects, and being in a good mood will release more healthy amounts of natural dopamine onto your body. How does a roller coaster affect this, you might ask? Well, look at it this way. You go to an amusement park and you feel motivation to ride a roller coaster. You, as a rider, get on the coaster and you feel good while you ride it. The forces that the ride pulls on your body give you a sense of pleasure, and after the ride is over, you feel accomplished. As a result, your body releases a large amount of natural dopamine. This can create a sort of addiction inside your brain, causing you to want more and more of this same sense of accomplishment. This might cause you to ride coasters over and over again, and even go out to different parks to get on other roller coasters. While dopamine is fun and is created when you have a good time on a roller coaster, there's also a reaction for being scared or nervous on a roller coaster. You see, a coaster puts you into a position where you don't have control over your body. Coasters pull some interesting forces that your body isn't used to feeling too. You can experience positive G-force, which is the feeling of being heavier than you actually are. The closest experience you can get that's not on a roller coaster is a fast acceleration in a car, or when you are swinging and you're in the valley or the lowest point of the swing. You can also experience negative G-force on a roller coaster, and this comes in the form of airtime. You can get two main types of airtime on a roller coaster. Ejector, which is more aggressive and the more violent of the two. This comes in short but strong bursts. Then there's floater, which is the more graceful and sustained of the two. Airtime feels like weightlessness as you are being lifted up out of your seat on a coaster. The two other more popular forces on a roller coaster are laterals and hang time. Laterals come during turns and it feels like you're being moved side to side. Hang time is, well, hanging for a long period of time during inversions. These come in the form of zero-G stalls and other super funky inversions. If done right, these also give you the sensation of weightlessness because there are 0 G's during the element. Now that you've had a quick crash course on the majority of the forces a coaster pulls, let's start talking about how they relate to adrenaline. But before that, we need to have a quick look at what adrenaline really is before we can start applying it to our experiences on a roller coaster. Adrenaline is the fight or flight sensation that we experience when we get into these intense situations. The hypothalamus in our brain activates our body's sympathetic nervous system, causing us to have these adrenaline rushes. This hormone makes us tense up, but also makes us extremely agile too. This is what gives us superhuman strength, which is why some people are capable of lifting cars when they have these massive adrenaline rushes. On a roller coaster, this reaction is caused by a reaction. It all goes back to the feeling of not being in control of what's happening. Your brain activates a special system and you have an adrenaline rush. Now, adrenaline can be both enjoyable and can even release dopamine, the fight sensation, or it can lead to fear and dissatisfaction, the flight sensation. When you ride an enjoyable roller coaster, you get an adrenaline rush and you feel on top of the world. Your body releases dopamine and it's a feeling that you crave. When you feel scared on a roller coaster, you still get an adrenaline rush, but you lash out and probably scream. Your body tenses up and you feel sick. The feeling of flight can make you very nauseous, but being nauseous, well, that's enough to make its own video out of. Something that seemed hard to do at first has now finally been completed. We have successfully related roller coasters to chemistry, but let's do a 60-second recap on all that we talked about today. There are two types of chemical reactions that happen in the realm of coasters. There are reactions that happen on the physical roller coasters themselves, and then reactions that happen on riders of a roller coaster. The main reactions that we talked about that happen on the physical roller coaster are the reaction of polyurethane wheels of a coaster melting due to the heat and friction, the wood of a wooded coaster aging faster in high-stress areas due to wear and tear, and also the fading of paint on steel coasters and the fading of wood on wooden coasters. Now let's do a recap on the reactions that happen to us, the rider. There is adrenaline, which leads to the fight or flight reaction. You get an adrenaline rush which can either make you feel nauseous or make you feel good. And when you feel good, dopamine gets released onto your body. Dopamine is a neurotransmitter, which is a feel-good chemical that your brain releases after you do something that you enjoy. Now, that's basically it. I hope you've learned something and enjoyed this video essay that got way longer than I would like to admit.